Hey guys, so this is week 9. We're going to do one more week of chemistry review, focusing on counting of atoms, evidence of chemical reactions, and the law of conservation of mass. So, again, just like last week, really important that you watch the entire video. So, after I'm done talking here really quick, there'll be an overview of the assignment of what you have to accomplish, and I'm keeping it consistent. You have a slideshow that you have to do, and then there's a form assessment that you have to do as well. So please don't forget that. Some of you are still forgetting to submit your work, so it's showing up on my end as not being turned in, but you're actually doing the work. So it makes it easier for me if you make sure that once you're done doing the work that you click turn in. Other thing, the opposite thing that's happening is some of y'all are just going and clicking turn in and you're not doing the work. So in case you haven't figured it out yet by looking at some of y'all's grades, I do check everybody's work, whether you turned it in or you didn't turn it in. So just because you turn it in, that's not checking off that you did it and you're going to get a grade for it. Okay, I go through and check to make sure that you answered all those questions. Okay, so make sure you're doing that. I'm pretty sure that this week, week 9, and next week, week 10, is it. That's it. The last week, going up until like June 4th, is really just an opportunity. I think, I can't guarantee it, for us to make sure that we're getting all of the other work in so that we can finalize grades for the year. I don't have any information on pass, fail, whether you are, whether you aren't doing the work, and how that's going to affect summer school. I don't know what summer school is going to look like. There's a lot of things we just don't know right now. So, to avoid all of those what ifs, it's always best to just do the work. Okay. So make sure that you're doing that. If you have any questions, make sure that you get with me. You should have been emailed a form to get your stuff. Like if you left stuff in any of your lockers, in the P locker and stuff, make sure that you fill out that form. You can't just show up unannounced. So in order to do that, you have to fill out that form so that we can schedule a time for you to come and pick that stuff up. So make sure that you're handling that. Other than that, like I said, we're almost at the end. A couple more weeks and we'll be done. So it's really important that you're keeping on top of your studies and making sure that you're doing the work. Again, nothing different this week. You have a slideshow broken up by day if you want to do it that way, or if you want to do it all at once, perfectly acceptable. And then you have the form. So make sure that you do both of those things and turn them in. Again, get with me, send me a private comment. I had a student get with me on Hangouts the other day and ask some questions. I'm available pretty much whenever, and well, except for 1 or 2 o'clock in the morning. But just ask questions if you don't understand. Let me know if there's anything I can do for you, okay? All right, guys, we miss you. Make sure that you're staying safe. Almost finished, and let's finish the year out strong, all right? All right, guys, bye. Okay, so this is the overview of the assignments that you have to do for this week. This is the second week of kind of a look back. Um, so this is week number 9, and then we'll have week number 10, and I think, pretty sure, that's going to be it for the school year. So we're going to spend one more week going over some important chemistry concepts that we've talked about already this year. Okay. So this is the week at a glance, um, counting atoms and chemical formulas, slide 3, 4, 5, and 6. Um, so that's a 2-day kind of a thing. So you'll do that on Monday and Tuesday. Um, so that's 2 days right here. On a Wednesday, evidence of chemical reactions. Um, there's a connection. There's 2 questions about that in the slideshow, slide 8 and 9. You're going to highlight the correct answer. And then on Friday, the law of conservation of mass. Again, like I've said every week, you don't have to break it up like this, but you can do it all at one time if you want, or you could break it up day by day. So Here, counting atoms and chemical formulas. This is a link to a video that'll help you understand that. Here's a page that kind of shows you how glucose is broken down. This number right here is a subscript, and that tells you that there are 6 carbons. This subscript right here tells you 12 hydrogens. This subscript tells you 6 oxygens. So when you're doing it, you have to be able to identify which ones are elements. And then these subscripts tell you how many of that element it is. So for example, if we look at H2O, this 2 tells you that there's 2 hydrogens, but because there's no subscript right here, that means there's only 1 oxygen. We don't write it, but it's just understood that there's 1. So for your assignment, this one should be easy because it's the example on the slide before. Here for sodium bicarbonate, you're going to type in listing the elements. So you list one element and then how many, another element, how many, another element, how many, because there are 3 elements here. Same thing here with isopropyl chloride. Don't be fooled here. Remember, all the C's don't have to be together. So there's 1 C here, another C here, another C here. Those 3 are carbons. However, this C is not carbon. This C goes with this L right here, so that's chlorine. So this is an element right here, and then we have your carbons, and then here we have your hydrogen, sorry. So be mindful of that when you're writing it down. So here in this yellow box, you're going to tell me how many C's, how many total H's, and how many total chlorines. And then here in the video that I did, there's instructions about how to deal with these parentheses. Remember that this 2 subscript outside the parentheses multiplies everything inside the parentheses. So you'll have to determine how many P's there are inside the parentheses and then multiply that times 2. And then how many O's inside the parentheses and then multiply that times 2. And so again, here, you're going to type in the elements like this, and then tell me how many of each of these elements there are. And those are all supposed to be question marks. Sorry. Okay. All right. Moving on. Chemical reactions. Again, the title up here is a link. So if you click on this, that'll take you to a video that'll help you. Also, if you watch the video that I made that goes along with this video at the end, I'll actually go through what the 5 pieces of evidence are. And so you'll have to type those 5 pieces of evidence in these 5 text boxes. So here are the 2 star questions. So here you got 2 different solutions. Here's the question, and so you're going to type your answer right here in this box, okay? This is the 2nd star question again, scientist observations. Read the question, type your answer in this box. And then the last part is the law of conservation of mass. And again, if you watch this entire video, I do a whole lesson at the end about what the law of conservation of mass means. And so here, you're going to be looking at these chemical equations and determining how much mass of nitrogen there should be. Remembering that there's 2 sides to every equation, and whatever we start with on this side, the reactant side, we have to end with on the product side. So if we're starting with 7 and an unknown amount of nitrogen, but when we add these 2 together, they have to add up to that. So that should make it pretty simple about figuring out how much nitrogen there is. Same thing here. We've got iron oxide plus hydrogen gives us iron and water. So you're going to be determining how much iron oxide there is by determining the total amount of mass on the right side. And that has to equal the total mass on the left side. So you have these 2 questions, and these two questions to do those problems and type your answers into these boxes. Okay. Along with that, there's again, as usual, a form that goes with that. So don't forget about doing the form and submitting that. Alrighty. And again, if you haven't done anything in the past or missed week 5, 6, 7, or 8, you always have time to kind of go back and do that. Alrighty. If you have any questions, again, always get back in touch with me. Let me know if there's anything I can do to help. Miss you guys. Be safe. Take care. Okay, guys, so the first part of your assignment is going to be asking you to count atoms. So before we kind of practice and go back over that concept, we need to make sure that we understand a couple of things. This is a element symbol, and it represents the element hydrogen. This is an element symbol, and this is an element symbol. So one of the first things you need to make sure you know is that in this chemical formula, that's a chemical formula, this whole thing is a chemical formula. There are 3 elements: hydrogen, sulfur, and oxygen. Now, these numbers right here, those are called subscripts, and they tell you how many atoms of the element are there. So, for example, here, because this 2 is next to the H, that means that there are 2 hydrogens. Now, sulfur here is sitting here, but it does not have a subscript right here. So if there's no subscript, that means there's only 1 atom. And the reason, because I wouldn't have put the S for sulfur there unless there was at least 1. But I don't put the 1. So the only subscript numbers you'll see are those numbers that are higher than 1. And then here, the third element, oxygen, this 4 right here tells us that there's 4 oxygen here. So if we're counting atoms, there's 2 hydrogen, 1 sulfur, 4 oxygens, and the total number of atoms here is 7. Okay? Now, you are going to have to deal with some parentheses, so let's talk about this one. So notice that this is an element symbol as well. Remember, some of the elements are symbolized with 2 letters, 1 upper and 1 lowercase. So Na is the element symbol for sodium. So that's one of the elements here. There's a capital S here, so there's sulfur in this one, and a capital O, so there's oxygen as well. So this 2 tells us that there's 2 sodiums. Now we have to deal with these parentheses, okay? And the best way to do that is just to kind of ignore that they exist, first of all. And what you see is 1 sulfur and 4 oxygens, but because it's inside these parentheses, this 2 multiplies everything that's inside of it. So that's 1 times 2 and 4 times 2. So there's actually 2 sulfurs and 8 oxygens. So for a total of 2 plus 2 plus 8. So the total number of atoms in that chemical formula is 12. Okay, the next part of the assignment is asking you to watch a video that's connected to the slides, but it's talking about evidence of a chemical reaction. There are 5 things that we look for. So if you think back to the lab that we did at the beginning of the year, where we put the 2 white substances in the Ziploc bag, and we added some phenol red, this red liquid solution, and then we immediately sealed the bag when we mixed everything together. We basically kind of saw all of the things that is evidence of a chemical reaction. Remember, evidence is little things here and there that you look for that tell you something happened. Okay, so for example, if somebody walks into class with a black eye, that's evidence that somebody hit him or he ran into something, right? So evidence are these clues that can tell you that a chemical reaction occurred, and there's 5 of them. Okay, so one of the first things we're going to look for is there a color change. Now remember, one thing only isn't enough to say that with 100% accuracy that a chemical change occurred, because when we make Kool-Aid or we put food coloring into water, we see a color change, but that's not a chemical reaction. That's actually a physical change. So color change by itself does not indicate that a chemical reaction occurred. Now, if you see color change with some of these other pieces of evidence, then that would suggest that a chemical change occurred. The next one is a gas production. Is there a gas being produced? And so some things that we would see that tell us that a gas is being produced are bubbles, if we see smoke, if we smell an odor. Those are all little pieces of evidence that say that a gas is being produced. Temperature change is another one. So if the substance gets hot or if the substance gets cold, that is a piece of evidence that a chemical reaction occurred. The fourth one is the formation of a precipitate, and that is a solid that forms when you mix 2 liquids. And then, of course, the ultimate evidence that a chemical reaction occurs is that a new substance is formed. So those are the 5 pieces of evidence that we're looking for to say that a chemical reaction occurred. Okay, so the next part is understanding the law of conservation of mass. And so the law of conservation of mass says that matter cannot be created or destroyed. It can only change form. So basically what that means is everything that we have in the world today, the walls in your house, the floor that you're walking on, the material that your Xbox or any other thing that you possess is made up of stuff that has been on Earth forever and been in the universe forever, but has gone through multiple changes to become the thing that it is today. Okay, and then as we move forward and that stuff gets thrown away or recycled or whatever, the material or the atoms that make that stuff up will just rearrange and form new things. We can never destroy it. Okay, all we can really do is change. So here in this example, this is photosynthesis. This is what plants go through to make their own food. So we're taking this substance, carbon dioxide, mixing it with some water and a little bit of sunlight. And then a chemical reaction occurs inside the chloroplasts of the cells that produces this substance, which is glucose, and this substance, which is oxygen. Now, the law of conservation of mass says what we start with, we have to end with. But this equation does not follow the law of conservation of mass because we started over here. So this is what we start with. These are called the reactants. Over here, we only have 1 carbon. We have 3 oxygens, 2 here and 1 here. And we have 2 hydrogens. But over here, we have 6 carbons, 12 hydrogens, and we have 8 oxygens. So because these numbers do not match these numbers, this does not follow the law. Now we can change things by putting coefficients in front of these. We're not going to mess with that because as an 8th grader, you don't really need to know how to balance an equation. You just need to be able to recognize that the equation does not or does follow the law of conservation of mass. So in this situation, this equation does not follow the law because these numbers here and here do not match. Okay, so we are not we're not ending with what we started with. Okay, and the last part of the law of conservation of mass is not only starting with the same number of elements, like here, we have 2 hydrogens on the left and 2 hydrogens on the right, but we have 2 oxygens on the right and only 1 oxygen on the left. So this equation as it sits does not follow the law of conservation of mass, okay? But we can also look at the masses of the substance. So for example, let's say I start with 7 grams of hydrogen and I get 24 grams of water. I need to know how many grams of oxygen do I need to make this equation correct. Okay, so 7 plus some number has to equal 24. And this is really simple math you should all be able to do. So in order to find out how many grams of oxygen I would need, I would take 7 and subtract it from 24, and that would mean that I would need 17 grams of oxygen, 7 grams of hydrogen. Combined together will make 24 grams of water. Now down here, let's say we start with an unknown amount of hydrochloric acid, and we start with 7.1 grams of sodium hydroxide, and then we end up with 38.1 grams of salt and 5.6 grams of water. So we need to figure out how much hydrochloric acid we started with. So we add these two together, and that'll give us a total of 43.7 grams. 7.1 grams here. So we need to know how much hydrochloric acid would belong there. So we take 43.7 and subtract 7.1, and we get 6. So the answer would be 35.6 grams of hydrochloric acid plus 7.1 grams of sodium hydroxide would give us a total of 43.7 grams on the right hand side.